All right, now real quick, a word about displacement versus total distance traveled. So displacement, another way of saying that is the net change in position. And to find the net change of anything in AP Calc that is changing, you take the integral of the rate function, which is the derivative. So yeah, so net change in position or displacement, we would take the integral of the velocity function. And then total distance traveled, you would take the integral of the absolute value of the velocity function. So let me just talk about these two things just real quick. And there's really not much calculus involved like right here, but all right, so let's suppose that I have a particle that is like moving along the x-axis. Okay, so this is the x-axis. So the function x of t, for at these inputs, so these are seconds, and then this is position. So at second 0, before we even start, we're at position -3 on the x-axis. And then after 1 second passes, we have moved to position 5, so we're at position 5. After 2 seconds have passed, we are then at position -2, and then after 3 seconds, we're at position 7. So the way that this particle moves is after, so 1 second, 2 seconds, 3 seconds. So it's going in that thing, in that motion. Now, the net change in position. So at second 0, so net change in position from t equals 0 to t equals 3. Okay, at t equals 0, we've got, so that's x of 0, we're at this position, -3. And then at t equals 3, our position is 7. Okay, so really the net change in position, I did this kind of backwards. The net change in position is 7 minus -3. It's 10. So the net change in position, 10 units from beginning position. All right, so that's the displacement or the net change in position. But the total distance traveled, guys, is different. Okay, the total distance traveled from 0 to 1 seconds, we travel from -3 to 5. Okay, from -3 to 5, that's 8. Okay, -3 to 5 position. All right, we travel 8 units. Plus, okay, so in the first second we've traveled 5. No, we've traveled 8 units. After the second, okay, and then from second 1 to 2, we travel back this way. That's 7 units plus 7. Okay, because from 5 to -2 is 7 units. And then from second 2 to 3, we travel from -2 to 7. That's a total of 9 units. Okay, so from 0 to 1, you travel from -3 to 5, so that's 8 units. From 1 to 2, you travel from 5 to -2, that's 7 units. From 2 to 3, from -2 to 7, that's 9 units. So 8 plus 7 plus 9 equals 24. Okay, why is this greater? Okay, why? So this is the displacement. This is the total distance traveled. Why is the total distance traveled greater? Why greater? Because the particle changed direction. Okay, it didn't get from A to B in a straight linear path. It changed direction. So it kind of went like off course. Okay, now let's just show another example. Here's a case. Seconds, position, x-axis, same situation. At second 0, we're at position 3. At second 1, okay, from 0 to 1, we move to -2. From 1 to 2, we move to 0. From 2 to 3, we move to 7. All right? So, the net change in position is the same. Okay, it's x of 3 minus x of 0. So, it's 7 minus -3. So, ending position minus starting position. All right, so there's the displacement again. But this time, the total distance traveled from 0 to 1 seconds, we move 1. From 1 to 2 seconds, we move 2. And then from 2 to 3 seconds, we move 7. So that is 10. So here is a case where the net change in position, or the displacement, is equal to the total distance traveled. Why are they equal this time? Because the particle never changed direction. Okay? And then that brings us to, for numbers 4, 5, and 6, I'm going to do a problem that will be like them. Okay, so for numbers 4, 5, and 6, you want to use this fact eventually. If the net change in position is equal to the total distance traveled, and another name for net change in position is displacement, then the particle was traveling in the same direction over the time interval. Okay, then so the particle never changed direction if these two are equal. If they are not equal, then it'll always be this, which is bigger, and then that means that they had changed, the particle had changed direction at some point. Okay, so page 4, number 1 from your packet, you're given a velocity function, you're given a time interval. First, they want the displacement. So I think, okay, so I'll just say displacement. First, they want you to set up an integral for it. So it's going to be the integral from 1 to 5 of the velocity function. All right, so that's part A. Then, so they want you to show this integral and then use Math 9 to get an answer. And you have to make sure you're in radians if it's trig. So Math 9, 1 to 5, 10, 9. Okay, so I'll say 2.176. That's good. All right, so that's the displacement. Then total distance traveled, you do the integral from 1 to 5 of the absolute value of the integral, or of the input of the velocity. Okay, so to get that, I do math 9, 1 to 5. Okay, but to do the absolute value, you go to hit math, and then over to number, and then you hit enter. It's that first one. Okay, and then 10 sine x squared. It's thinking. Let me grab the packet while it's thinking. Okay, so this is, all right, and now, so I grabbed the packet. So now we're on part E. During the given time interval, did the particle ever change direction? Explain your answers to be, or using, Explain your answers to B and D. What? Oh, wait, explain using your answers to B and D. Okay. So I will say, so this is for part E. Did the particle ever change direction? No. Because we could be like total distance traveled. The total distance traveled by the particle is greater than its displacement. Or you could say net change in position. Okay. All right, guys. So how about, let me think. All right, I guess that was kind of a long chunk, so I'm going to make a third video for the remainder of the test. Okay.